Hi, I'm Rolando Umawan and welcome to Lesson 4, Implementing EA Standards and Profiles. Topics to be discussed are standards for EA and for service-oriented architectures, and EA profiles and reference models. Standards for EA and for service-oriented architectures. The enterprise architecture standards are the results of years of international academic research and industry expert consensus on repeatable patterns that can be reused and replicated. They have been specifically designed to be fully tailored to and implemented by any organization, both large and small, regardless of its various frameworks, methods, approaches, products, services, and activities. The enterprise architecture standards are developed in the following ways. Research and analyze what works, again and again, which are the best practices, and discover the unique aspects applied by leading organizations or leading practices. Identify common and repeatable patterns which provide the basis for the enterprise standards. Develop reference content that increases the level of reusability and replication within the discipline of enterprise modeling, enterprise engineering, and enterprise architecture. Extend with performance and value accelerators with unique aspects from the identified best practices and leading practices. First, we start with the definitions. What is service-oriented architecture? Service-oriented architecture, or SOA, is a style of software design where services are provided to the other components by application components through a communication protocol over a network. Its principles are independent of vendors and other technologies. In service-oriented architecture, a number of services communicate with each other in one of two ways, through passing data or through two or more services coordinating an activity. SOA-based services are modular swappable functions, separate from yet connected to an application via well-defined interfaces to provide agility. Often referred to as services throughout this document, they perform granular business functions such as get customer addresses or larger ones such as process payment, are loosely coupled to a new or existing application, or have capability to perform the steps, tasks, and activities of one or more business processes, and can also be combined to perform a set of functions referred to as service orchestration. State SOA backbone is defined as shared common infrastructure for lifecycle management, such as services registry, policies, business analytics, routing or addressing, quality of service, communication, development tools for security, management, and adapters. Service providers and consumers are in general entities, which are people and organization that offers capabilities and acts as service providers. Those with needs who make use of services are referred to as service consumers. Service conditions and planning design standards. SOA-based applications modules are constructed to meet service conditions. Planning design standards are provided in order for the service to meet the desired condition. Each service provider is largely autonomous, addressing one function or set of related functions. Modularity enables loose couplings and helps make components swappable because a service provider can be replaced without causing unintended side effects. The first one is that the service must be modular. This enables flexibility to solve complex problems by assembling a set of small and simple components that work together. These services shall be designed to be loosely coupled, and these services interfaces must be clearly defined and documented. Developers shall enter interface metadata or use tools to generate interface metadata that specifies an explicit service contract so that another developer can find and use the service. Everything needed by the service to provide its functionality must be passed to it when it's invoked, such as service boundary explicitness, and all access to a service must be via its exposed interface. No hidden assumptions must be necessary to invoke the service. Business analysts and architects shall collaborate to ensure business processes are unique, well-defined, and documented, and that service candidates are capable of meeting business needs and changes. Next is the modules must be distributable. Service components are able to run on disparate computers and communicate with each other by sending messages over a network at runtime. Services are typically spread out over multiple physical locations. A service must be used by multiple consumers. SOA applications are inherently distributed applications. The service provider shall be responsible for creating a service contract for each service and negotiating with each service consumer. Service contracts shall be posted on the state of ICC SOA service registry to communicate information about the service. Number 3. Module interfaces must be discoverable. Service components are able to run on disparate computers and communicate with each other by sending messages over a network at runtime. Service naming. Services must be ambiguously named based upon their purpose and to best represent the task in what is known as the real-world effect. Services usually map to a business task. The name of the service must be encapsulated the essential aspects of the real-world effect of the service. That is, the name of the service must represent what the service accomplishes in business terms, rather than how the service works. For example, verify zip code, verify correct address are representations of services based on or named after the real-world effect and are easily understood by business and technical staff. The name shall not indicate underlying information system that implements the service, nor the agency or organization that provisions the service, nor any technical details about how the implementation works. Service description. Services shall contain a complete description of the real-world effect of the service. It also must contain a list and brief description of each of the actions, and contain a list and brief description of the principal information and entities involved in the interaction with the service via its actions. All aspects of the description must be free of any implementation details or dependencies. The description shall not refer to particular databases or systems in the description of the real-world effect. Rather, the description must describe the business effects of the service. Service modules must be swappable. The service module can be replaced by another module that offers the same service without disrupting modules that use the previous module. This is accomplished by separating the interface design from the module that implements the service. This separates the implementation, which is the service provider module's code and data, from the interface metadata. A copy of the interface metadata is accessible to other developers separately from the code that implements the provider component. This makes it possible for the consumer developer to use the service without having a copy of the provider software module. It also enables multiple development teams to create interchangeable provider modules, which the consumer and the provider can use disparate programming languages, application servers, and operating systems. Number 5 is service provider modules must be shareable. Services must be designed and deployed in a way that enables them to be invoked successively by disparate applications in support of the diverse business activities. Multiple agencies, departments, or separate agencies and entities can use the same service. This service condition ensures each provider module is in an SOA application can be invoked successively by disparate consumers. Developers can write different consumer application modules that use the same service as long as they conform to the conditions specified in the interface contract. The next topic to be discussed is the enterprise architecture profiles and reference models. There are 6 reference models in the common approach to EA. 1. Performance reference model. 2. Business reference model. 3. Data reference model. 4. Application reference model. 5. Infrastructure reference model. And lastly, the security reference model. These reference models are taxonomies that provide standardized categorization for strategic business and technology models and information. This supports analysis and reporting across agencies, EAs, and each of the documentation domains. Each reference model will have its own taxonomy, methods, touchpoints, and use cases. The associated meta model will illustrate the relationship between the reference models with the use case, providing examples of how each reference model can be applied. The performance reference model supports architectural analysis and reporting in the strategy sub-architecture view of the overall EA. The PRM is both a taxonomy and a standard method for performance measurement, as it provides for a common approach to performance and outcome measurements. The PRM allows agencies to better manage the business of government at a strategic level by providing a means for using the EA to measure the success of investments and their impact on strategic outcomes. The PRM accomplishment this goes by establishing a common language to describe the outputs and measures used to achieve strategic objectives through copied business services such as mission and support. The PRM shows the linkage between internal business components and the achievement of business and customer-centric outputs and outcomes. Most importantly, the PRM helps to support planning and decision-making based on the comparative determinations of which programs and services are more efficient and effective. The PRM focuses on 3 main objectives. First is to produce enhanced performance information to improve strategic and daily decision-making. Number 2 is to improve the alignment and better articulate the contribution of input and outputs, thereby creating a line of sight to desired results. And last is to identify performance improvement opportunities that span traditional organization structures and boundaries. Business Reference Model. The Business Reference Model, or BRM, supports the architectural analysis and reporting in the business services sub-architecture view of the overall EA. The BRM provides a functional view rather than structural or organization chart view of organizations and their line of business, including mission and support business services. The BRM describes an organization through a taxonomy of common, shared mission, and support service areas instead of through a stovepipe single organization view. The BRM therefore promotes intra and interagency collaboration and serves as the underlying foundation for sector and federal-wide shared services and strategies. Data Reference Model. The Data Reference Model is the supporting foundation for the overall EA, with a focus on two core questions. What information is available for sharing and reuse, and what are the information gaps needing corrections? The DRM is designed to provide a flexible common framework for effective sharing of information across organizational boundaries, increase integration and reuse opportunities, and support semantic interoperability while respecting security, privacy, and appropriate use of that information. The DRM provides a standard means by which data may be described, categorized, and shared. These are reflected within each of the DRM's three standardization areas. First is data description. It provides a way to uniformly describe data to convey meaning, thereby supporting its discovery and sharing. Data context facilitates discovery of data through an approach to the categorization of data according to taxonomies. Additionally, enables the definition of authoritative data assets within a common operating environment, and data sharing, which supports the access and exchange of data where access consists of ad hoc requests such as query of a data asset, and exchange consists of fixed reoccurring transaction between parties. This is enabled by capabilities provided by both of the data context and the data description standardization areas. Application Reference Model. The Application Reference Model, or ARM, supports the architectural analysis and reporting in the application sub-architecture view of the overall EA. The ARM is a component-driven taxonomy that categorizes the system and application-related standards and technologies that support and enable the delivery of service components and capabilities. Infrastructure Reference Model. The Infrastructure Reference Model, or IRM, supports the architectural analysis and reporting in the host infrastructure sub-architecture view of the overall EA. The IRM is a component-driven taxonomy that categorizes the network cloud-related standards and technologies to support and enable the delivery of voice, data, video, and mobile services, components, and capabilities. Security Reference Model. The Security Reference Model, or SRM, supports the architectural analysis and reporting across all of the sub-architecture views of the overall EA. This provides a roadmap that assists agencies in integrating IT and security privacy within the EA. It provides a mechanism for identifying security and privacy requirements. It promotes inclusion of security and privacy in business activities and processes, and integrates the NIST risk management framework and the organization system development lifecycle processes to ensure that relevant security and privacy requirements are integrated and continuous monitoring is implemented. This is the end of the presentation. Thank you for listening. I hope you have learned something today. Thank you. Here are the references for this report.